Hi everyone. Today we are going to discuss Jacobian. That is a very interesting topic of engineering mathematics. In this session, we are discuss about examples on Jacobian, that is the form j into j dash is equal to 1. So what is the j and what is the j dash? J dash is called as its reciprocal of, that is a j, means j into j dash will have to getting here result 1. So let me start in this session the examples based on, that is j into j dash is equal to 1. So before the starting this example, I wanted to discuss here some topics or some process how to find the solution of the type j into j dash. So let's see here, type j into j dash, type here j into j dash, and that is equal to here 1. I'm going to discuss here, so let's see what is this type and how to solve this. If u is a function of xy, so I'm writing this here, let if u is a function of here some function f1 of x comma y, v is a function that is f2 of x comma y, means u and v are the functions of xy, and I'm writing here that x is a function of phi of u comma v. So I'm writing now this in this way, x is a function of u comma v, means we have to denote this function now as, and x is a function of, that is a phi of, means I'm saying the first function, that is phi 1 of u comma v. Similarly y is equal to here phi 2 of here u comma v, right? Then what is the definition of this Jacobian? So u is a function of clearly xy, means that is I am writing here once again for clarification, I'm just writing here. So that is u is a function of here x comma y, and these x comma y are function of here u and v. So it means says that then dabba uv upon dabba xy, means u and v are the functions of xy, that's why we have to find its Jacobian, into xy is again function of uv, so dabba xy upon dabba uv. So you will have to getting here the result is 1, so that is this Jacobian of uv with respect to xy, this is denoted by suppose j into, this is denoted by now this j, and it's a reciprocal. You see here Jacobian of uv with respect to xy into Jacobian of xy with respect to uv, so there is another notation we call, there is j dash, and that is equal to here clearly 1. I hope so you have to understand this, what is a j and what is j dash. So similarly here, if u is a function of here, u is f1 of here x comma y, right, and v is a function of here, that is f2, some function is here x comma y, are the functions of x and y, are functions of, right, x and y, are given, means you have to given only u and v are given to you. Then first find directly, what we have to find directly we have to find j, and j is nothing but u is a function of xy given to you, that is a dabba uv upon here dabba xy, we have to find it directly, right? And that is the first you have to find out this, right? And for j dash, that is dabba xy, j dash means what is that? It's a reciprocal of j, dabba xy upon dabba uv, right? we have to find here x and y are the functions of uv, right? So for that first we have to find x comma y are functions of here u and v, and this can be extended for three functions also. So this is applied for three functions also, therefore this is applied for three functions also. Three functions or three variable is there, variable, and so on. Actually this is a process to find j into j dash that is equal to 1, means this is a process of the type j into j dash is equal to 1. Also you have to remember that you have to suppose verify j into j dash is equal to 1, at that time you do directly j dash is equal to 1 upon j. So for that we have to take one more result. So j is nothing but here, j is nothing but 1 upon j dash, or here j dash is nothing but here 1 upon here j. So you will have to use again these two formulas here. We have to use again these two formulae. For if j is a given, it will take only reciprocal, we have to getting the j dash value. I hope you have to understand this. Yes. Now after explaining these type, I am going to discuss here type number that is 2, that is j into j dash is equal to 1. So let me start some example we solve here. The example on j dash is equal to 1. So let's see. I am writing the example first. So example number 1. If x equal to here u cos v, comma y equal to here u sin v, prove that dabba x comma y upon dabba uv into dabba uv upon dabba xy, that will equal to 1, means result should be equal to here 1. So let me start how to solve the solution. So solution here. So let you have to find first dabba xy upon dabba uv. So clearly you will have to given let x equal to here u cos v, comma y equal to here u sin v. So that is here x comma y are the functions of here u comma v. Therefore you have to immediately find out its definition. So you know that by definition of Jacobian, you know very well the definition of Jacobian is what. So it is nothing but capital J, and J is nothing but it is a determinant of. So I am going to discuss now here. Now this Jacobian can be right now in this way, that is it is a determinant of 2 by 2 determinant. What is that? Dabba u by dabba x. So here clearly you have to given x and y are the functions of u and v, so that we have to just calculate here. What we'll have to calculate? Dabba x upon here dabba u, and dabba x upon here dabba v. Similarly dabba y upon dabba u, and here dabba y upon dabba v. So you have to first calculate this, and we call that is a Jacobian of xy with respect to Jacobian of here u comma v. I hope you have to understand this very well, right? So for consideration we call that is equation number 1, because I am going to again use this function, right, for that. So we have to just find these values. we have to just find these values. So let's see. So therefore Jacobian of this determinant, this can be written as, so I am writing directly values in this equation. So let's see here, I am calculating the values. So x and y is given to you, so what is the dA by x upon dA by u, and here dA by x upon dA by v. So you have to find these values. So dA by x upon dA by u, differentiation of u cos v is a constant, therefore it is only cos v is there. Then again with respect to v, cos v differentiation minus sin v, u as it is, so minus u sin v. Again you have to just calculate here dA by y divided by dA by u and dA by y divided by dA by v. So similarly you will have to take these values now in this way. DA by y divided by dA by u, then v term is a constant, means terms of v is a constant, so sin v is a constant, and derivative of y with respect to u, that is only sin v is there. Also differentiate this y with respect to v, means here u is a constant, u treated as a constant, and derivative of sin v is a cos v, and using these values in this determinant, so dA by x by dA by u, that is a cos v, dA by x by dA by v, that is a minus u sin v, right? Then dA by y upon dA by u, that is a sin v, right? And then here is a u cos v. I hope you have to understand this j is what, and just you have to calculate this is what, this is taking cross multiplication, that is a cos v into u cos v. Now this minus minus there will be plus, that is a u sin v into sin v. So after taking some simplification, cos v, that is a v into cos square v, so that is u into cos square v plus here, so what is that here, yes, u into cos square v plus u into here sin square v. So again I am taking the simplification now, is u is a common, and cos square v plus sin square v. By using the trigonometric identity, so you have to get the value is simply, what is that, u. You have to get the value is simply u. So Jacobian, that is a j, that is a dA by xy, dA by xy upon dA by uv, you will have to getting here only u. So since I am using the result is here, what is that here, cos square theta plus sin square theta, that is equal to 1. That is a trigonometric identity we have to use. If j is u, then you have to just show that j dash is what is that, here is also 1 divided by u. But let me solve, or let me here simplifying, and you will getting the answer here 1 by u. So this is a second for consideration, this is equation number second, right? Now let me start how to find the j dash. Now we have to find j dash, and j dash is nothing but it is a dA by uv upon dA by xy, dA by uv upon dA by xy. That is, we have to first find uv as a function of xy. That is, we find first u comma v as a function of x and y. So for that, let you have to given x is equal to, what is the given, u cos v, and y is equal to u sin v. So just you have to eliminate value of v. So therefore I am taking the squaring and adding. So therefore here is x square plus y square is equal to here u square, and cos square plus sin, means cos square v plus here sine square v. What I am doing here, so I am doing only squaring and adding this above value, and using the result you will get us square equal to simply x square plus y square. So again I am using the result as, that is sine square theta plus cos square theta, that is equal to here 1. I am again using this 1. So taking square root on both sides, what will get value of u is nothing but here is under root here x square plus y square. So similarly you have to find v, is how to find v. So this is u, so immediately you have to calculate what is the dia by u divided by dia by x, dia by u divided by dia by x. So therefore dia by u divided by dia by x, because u is a function of xy, so what will you get its value, that is 1 upon 2 under root x derivative, that is 1 upon 2 under root x square plus y square, and with respect to x, that's why its derivative is, what is that, 2x. So what will you get here, dia by u by dia by x. So clearly this is 2 get cancel here, x upon under root x square plus y square, x square plus y square. So again you have to calculate similarly dia by u divided by here dia by y. So you will have to getting again 1 upon 2 under root here x square plus y square, and differentiate with respect to y, treating y as a constant, it will get y square derivative it is a 2y, again 2 is cancel, and remaining is y upon under root here x square plus y square. Right? So similarly now taking, for finding the value of v, let we have to just use the given equation, that is x divided by u means here y by x. So what is the y divided by x? Y means here u sine v, and here what is that, u cos v. So you get cancel here, sine v upon cos v, that is a tan v. So that implies what is the value of v? V is nothing but here tan inverse of here y by x, tan inverse of y by x. So here clearly u is a function of x and y, therefore immediately you have to find out here dia by v upon dia by x. So dia by v upon dia by x. So what is the dia by v by dia by x? So how it will be calculated this? So 1 tan inverse x, derivative of tan inverse x, it is a 1 upon 1 plus x, means it is a 1 upon 1 plus x, means here y divided by x, and it's a square. And again derivative is the remaining derivative of, what is that here, y divided by x, again derivative of this y divided by x. So it will get, treating y is a constant and 1 by x derivative, that is a minus 1 upon x square, so it will becomes minus y upon x square, So therefore after taking some calculations, dia by v divided by dia by x, so it is what, that is taking LCM of a denominator and making this simplification, you will get the value as that minus is merges into plus sign is there, so you will have to getting the value is x upon here x square plus y square, this is value of, sorry, this is not x, this is a minus y upon, because of that y is here, so this is minus y upon x square plus y square, minus y divided by x square plus y square. So similarly you will have to getting dia by v divided by dia by y. So what is the replacement here? Only, that is y is replaced by x, minus y is replaced by x, and again x square plus y square, So for references we call this is equation 3 and this is equation 4. It means These both are equation 3 and both are equations 4. So by using the values of equation 3 and equation 4, you will have to getting the J dash. So therefore dabba u divided by here dabba x, the value becomes here x upon under root x square plus y square, x upon under root x square plus y square. Dabba u divided by dabba y, the value becomes here y upon under root x square plus y square. Dabba v divided by dabba x, the value becomes minus y upon x square plus y square, and dabba v divided by dabba y, that is equal to x upon x square plus y square, x upon x square plus y square. So therefore J dash can be written as, J dash means it is a Jacobian of uv with respect to here xy, Jacobian of uv with respect to xy. So it is just like 2 by 2 determinant. What is that here? Dabba u by dabba x, dabba u by dabba y, dabba v by dabba x, and dabba v by dabba y. So just you have to observe and put up the values in this equation. So what you will get, it becomes, so this is first value, that is x upon dabba u by dabba x, that is x upon under root here x square plus y square. Second, dabba u by dabba y, that is y upon under root here x square plus y square. In second row, dabba v by dabba x, this is a minus y upon x square plus y square, and this is x upon x square plus y square. So this is a determinant, and just you have to hit solve. So therefore the Jacobian is equal to, taking cross multiplication, so what will you have to get? This is x into x, x square upon this value, means what is that here? X square upon, what is that? Under root x square plus y square, that is under root x square plus y square, inside the bracket x square plus y square, right? Plus y square, means this minus minus, that will becomes plus y square upon here under root x square plus y square, and inside the bracket here x square plus y square. After taking or after solving this determinant, you will have to getting this value. I hope so you have to understand this. Therefore this denominator will be also same, so this can be also solved by, that is x square plus y square. Therefore common denominator I am taking here. What is that here? Under root x square plus y square, inside the bracket x square plus y square. Now this total term get cancelled here, right? This total term get cancelled here, and what will remains here? That is, therefore what will remains, that is 1 upon under root here x square plus y square, 1 upon under root x square plus y square. But what is that under root x square plus y square? So this is nothing but this is a value of u, right? This is nothing but this is a value of 1 divided by u. Because of that, since u is equal to, that is under root of x square plus y square, right? For that reason we have to use this. So J dash is equal to, what is that? U. Hence J into J dash, that is equal to dabba xy upon dabba uv, that is this Jacobian J into Jacobian uv upon Jacobian xy, that is equal to, that is u into 1 divided by u. You will get the required result is 1. You will get the required result is 1. I hope so you have to understand this question very easy way. So this is a proof. This is a proof. Understood it? Now after the example number first, we have to discuss the example number second. Let's see. Example number second. If x equals to u in bracket 1 minus v, right, y equal to u comma v, then prove that the result j into j dash, that is equal to 1. So j means what, j dash means what, we have to calculate it, and after we have to prove this. So let's see the solution. Given that let x equals to here u in bracket 1 minus v, y equals to here u comma v. For consideration, we call that is equation number 1. So immediately we have to apply the definition of Jacobian. So Jacobian J is equal to, it is dA by uv upon dA by xy, right? DA by uv upon dA by xy. So dA by uv upon dA by xy means it is a determinant of dA by u by dA by x, dA by u by dA by y, dA by v by dA by x, and dA by v by dA by y. So we have to just use this determinant, put up these values in this determinant. So I'm directly put up these values in this determinant. So differentiation of u with respect to x, but instead of that you have to just learn about what is functions are given to you. Means here x and y are the functions of u and v. So for that, let me first write so that is x comma y are the functions of here u comma v. So therefore differentiate partially u comma v with respect to, so not u comma v is here differentiate partially x comma y. Because of that, xy is a function of uv. Differentiate partially x comma y with respect to u and v, right? So therefore, what is the dA by x divided by dA by u? So let's see. So x is given with respect to u taking as derivative, and the other term as a constant. Means when we differentiate with respect to u, v as a constant, v treated as a constant. Means dA by x by dA by u, it is clearly 1 minus v. Next, dA by x divided by dA by v. So you have to just see here, treating u as a constant and derivative of 1 minus v. Treating u as a constant and derivative of 1 minus v. So it is what? It is a clearly u as a constant and minus v derivative minus 1, and 1 derivative is 0. So that value is a minus u only. Also dA by y divided by dA by u is what? DA by y divided by dA by u, it is a clearly v, and dA by y divided by dA by v, it is u. So using these values we have to just write the Jacobian. Therefore Jacobian, I will have to calculate here Jacobian of uv with respect to, what is that? Not uv is, again I am writing now Jacobian of xy is there only, right? Jacobian of xy with respect to u comma v. So definition is, what is that? Definition is dA by x divided by dA by u, dA by x divided by dA by v, dA by y divided by dA by u, and dA by y divided by dA by v. So therefore this is equal to, right? So dA by x by dA by u, what is that? DA by x by dA by u, this is 1 minus v. DA by x by dA by v, that is a minus u. Next value becomes v and then u is there. So just you have to simplify this Jacobian. So 1 minus v into u minus minus plus u into v. So this is nothing but x plus y. You have to observe the given values. This is nothing but x plus y. So since given, right, 1 minus v into u and uv is y. So therefore Jacobian is equal to simply x plus y, right? This is equation number 2. Now to find j dash, right, to find j dash, and j dash is nothing but dabba uv upon dabba xy. For that we have to find uv in terms of xy, u comma v in terms of x and y. So therefore from equation 1, so what is that here? X equal to u in bracket 1 minus v, and y equal to u comma v. So x is nothing but u into minus u minus uv. So that is x equal to u minus y, right? And that implies y is equal to, that is u in terms of u, that implies u equals to x plus y, u equal to x plus y. So that implies this. So therefore this is equal to, and v is equal to here y divided by u, v in terms of y by u. Y by u means what is that here? This is y divided by value of u. U is nothing but here x plus y, right? X plus y. So let's see. You have to observe what is the value of u, right, and what is the value of v. V is nothing but y upon x plus y, right? I hope so you have to understand this, what is the value of u and v. So let's see. Now for finding j dash we will proceed further here. So let here j is equal to means I am writing the value of directly u and v is there, right? Directly u and v. So therefore u is equal to x plus y, and v is equal to y upon x plus y. So for reference we call that is equation number 4. So therefore dabba u divided by dabba x, keeping y as a constant, its derivative is only y. Next dabba u divided by dabba y, therefore this is equal to here only x, not this derivative too much. This is dabba u by dabba x, means you will get only 1 because of that x plus y, keeping other variable as a constant. So therefore dabba u divided by here dabba x, that is equal to 1, y derivative 0, right? Dabba u divided by dabba y, that is also equal to 1. Here dabba v divided by dabba x, dabba v divided by dabba x, treating other variable as a constant, means y upon 1 upon x derivative, that is a minus 1 upon x plus y square, and derivative of x is 1. So this derivative now is in this way, minus y upon, so this is equal to minus y upon x plus y whole bracket square, minus y upon x plus y whole bracket square. Similarly dabba v by dabba y, that is equal to, this is what keeping other variable as a constant means numerator and denominator is, therefore you have to use a quotient rule. So quotient rule was denominator into x plus y into derivative of numerator, it will be 1 minus numerator into derivative of denominator, it will be also equal to 1 divided by denominator square, means x plus y whole bracket square. So it will take the values, that is x plus y minus y upon x square, means I am writing this x plus y whole bracket square, not x square, x plus y whole bracket square. This is x upon y and y get cancelled, x upon x plus y whole bracket square. So using the partial derivatives of u and v, you have to find j dash. So j dash is defined as, so therefore j dash is defined as, that is a Jacobian of u comma v with respect to here xy, with respect to here xy. We have to put up these values in the Jacobian. So this can be written as, that is a dabba u by dabba x, dabba v by dabba x, dabba u by dabba y, dabba v by dabba y. So let me write here the values. So what are the values? So first dabba u by dabba x, that is a 1. Next dabba u by dabba y, that is also equal to 1. Next value dabba v by dabba x, that is a minus y divided by here x plus y whole bracket square, and next value x upon here x plus y whole bracket square, right? So this is a value, right? So taking just a cross multiplication is here, so therefore the j dash is equal to, therefore the j dash is equal to, this is x upon here x plus y whole bracket square. Now this minus minus, that will get plus y upon here x plus y whole bracket square. So this will get x plus y upon here x plus y whole bracket square. So what is that here? 1 upon x plus y. So therefore j dash is equal to 1 upon x plus y. So for consideration, this is equation number 5, right? So from equation 4 and 5, not this is 4, actually equation 3 and equation 2 and 5. So I am writing here the equation 2 and 5. 2 and 5, you will get j into j dash, that is equal to, j is x plus y into 1 upon j dash is x plus y. So this will get clearly result is 1, so that implies j into j dash is equal to 1, hence the proof, hence the proof. I hope you have to understand this very well. What is your proof of the problems of the type j into j dash is equal to 1? In this session we covered 2 examples of j into j dash is equal to 1. I hope so you have to understand this session very well. Now this is example and these are the proof. So let's see the check here how to find j into j dash problem, and we have to show by property number 2nd, that is j into j dash is equal to 1. I hope so you have to understand this very well. Thank you guys.